Hi, I'm David Smith, and I want to talk to you about this passion I have that I call the augmented conversation. Uh, the idea there is a very deep and powerful collaboration capability that I think is going to be essential for us moving forward. These ideas really came to a large degree from Dag Engelbart, uh, who I love this quote. The key thing about the world's big problems is they have to be dealt with collectively, and this is important. If we don't get collectively smarter, we're doomed. I actually believe that we're at that inflection point where we have to figure out how to be working collaboratively in a deep way because the systems that we're having to deal with are so much more complex than any single human can address. In 1968, Doug put together a demo that's now known as the mother of all demos that illustrated some of the ideas that I'll be talking about, but really showed off kind of this first idea of what computing really could be and should be. He, of course, is known as the guy who invented the mouse, but what he really built was so much more powerful and interesting than that. What I'm going to do is uh, show off of a little bit, a very small snip of a video from that demo he did. And I'll let him speak. But this is what you'll see here, uh, you know, from 1968 is sort of magic.
And so this special thing, if I label 13, will switch over. So in his display, he sees my text. So I'll execute it. And sure enough, it does. But what's that running around? Well, if he's looking at my text, he'd like to have something to say about it. So we put on a marker, a tracking spot that he controls. So he's sitting there in Menlo Park looking at this text, and he can point to it. But we've carefully reserved for me the right to control and operate on this. So my bug is more powerful than yours. But we can have an argument. Yeah. That's what they call a bug fight. So, all right. So in case you haven't been listening, Bill, we've been going through lots of examples and setting up in collaboration here so that we can go on into information retrieval. And we've set up now audio coupling, and then we're both looking at the same display, and that'd be very handy to work. We can talk to each other and point, and maybe later I can hand you the chalk on this blackboard, like saying, here, you control it. But let's stay this mode now and add another feature that hardware-wise is available through the kind of display we have. I'd like to see you while I'm working on it. So before I can do that, I have to set up my display in a certain way. Set it up so I see it over like that. That leaves a corner up there, and I say, now computer, do the automatic switching that'll bring in a camera picture from the camera mounted on his console, such as the camera mounted on mine is. Hi, Bill. That's great. Now we're connected audio. You can see my work, you can point at it, and I can see your face, and we can talk. So let's do some collaborating.
So I find that what you just saw was magic. I mean, you're used to Zoom today, but what was happening was a lot deeper than that, a lot more important. They were interacting with each other on their computers. It was a shared computer. I'll move this out of the way, and that was extraordinary to me to see just the whole scope of what he was doing. Brett Victor wrote this about what he was after, the shared intellectual space. Engelbart's vision from the beginning was collaborative. His vision was people working together in a shared intellectual space. His entire system was designed around that intent. And that was a very powerful thing. He wasn't thinking in terms of, oh, I'm going to make a mouse. It wasn't thinking in terms of features. He was thinking in terms of the quality of the users and their experience and what they could do together. In the same way, in the same year, Alan had a vision of the computing of the future that he referred to as the Dynabook. And what's really interesting, we have a lot of devices like iPads and phones that look very much like a Dynabook, but they're very, very far from what the vision of the Dynabook would be. Here's a picture that Alan took of a mock-up that he built. That's all cardboard. And what he did was on a plane ride back from seeing Seymour Papert, he did this drawing. And if you look at the screen, you'll see that they're the two children working together on something. In this case, they're actually playing Space War, but Alan describes it later as that they went from playing Space War to actually modifying the program of Space War collaboratively. They're looking, in different directions, but they're actually working together directly in a very, very deep, profound way. That led me to this idea that isn't really new. You're usually seeing the 68. A lot of those ideas already existed that I call the augmented conversation. And there's a number of features to this idea. First is it's a discussion with a group of users, is extraordinarily enhanced with the kinds of tools and capabilities that are only available at the computer. Remember, it's a group of users. I'm not just talking about screen sharing. I'm not talking about video. Second, computer AI is a full participant in the conversation. It allows us to jointly discuss, explore complex systems, data sets, and simulations as naturally as we talk about the weather. I used to think that this was something, I believe this is necessary, but I thought it's going to happen someday. And in fact, we're beginning to see the capability today. Google just demonstrated a platform that would fit really well into solving this particular part of the system. Finally, there must be this guarantee of shared truth. In other words, the simulation I see must be exactly the same as what you see. Anything I do to affect the shared simulation must be accurately shared. Otherwise, you don't trust the system. You won't believe that it's really what I see is what you see. And that's just so essential. So talk about the virtual objects that will soon populate our world have to be as responsive and alive as the physical objects. What you see is exactly what I see. I see what you do as you do it. And the way I know this is true, in the future, we won't be talking about physical reality and virtual or augmented reality. There's only going to be reality. And there's not going to be a distinction. Our children's children are going to be looking at this and say, what's the big deal? The digital and the physical are going to become one very shortly. And so Croquet was designed around this idea. Croquet is a protocol that enables dynamic, immediate, and perfectly synchronized interactions. Even complex simulations are shared. I really think of it as a missing protocol of the internet. And one nice thing is it's based on the idea of the end-to-end argument, which is the foundation of how the internet works. And I think this is a big deal. This is the team that actually created the basic idea of Croquet. It's me on the left, and you know about Alan. David Reed, among other things, he defined the idea of the end-to-end argument, which is the basis of the internet. He created UDP and he co-created TCP/IP. And Andreas Raab was essential. He was, among other things, co-developer of Squeak Smalltalk, but he was also probably the best programmer I've ever met. So how does Croquet work? Traditional models on the left-hand side, you have a client server, user interacts with a local view, message gets sent up the server, server computes and sends up back a lot of stuff that the view has to manage, including have to roll back or whatever. Croquet is on the right-hand side, user interacts with the view, and instead of having a server, we actually have a thing called a reflector. It's kind of a router that has no state, but what it does is it puts a timestamp on the message and it gets redistributed to all the participants. And what's happening is we have a shared virtual computer that's running bit identical on our systems. I'll be able to illustrate that a little bit more in a second, but imagine that I have a black box that's guaranteed to be exactly the same black box you have. It becomes something really magical when you can pull that off. I'm going to show that demo that I just mentioned. First thing I'm going to do is get this out of the way. And I've got two simulations running here. And indeed, they're the same one. So we've got this physics sim here. And I've got another one right here. And you can see that these are running bit identical. Now, it's not because they're running on the same machine. I can actually have these jump onto my phone or anywhere else. In fact, I'm going to put up a QR code here, and you can scan that QR code. Hopefully, the quality of the image is good enough, and you can have this simulation jump onto your phone. I'll also send out links so you can try it. But what you want to do is run it on your phone, on your PC, any devices, and see them side by side. So, for example, if I hit spacebar here on the top one, you can see it's that simulation. The interaction is perfectly shared. And notice you could use these as stereo pairs. So I'm going to move these out of the way. And so Croquet's got some really nice features. I mean, we designed it in from the start, but we got, I think, very lucky that we succeeded as well as we did. It's cheaper, there's like no overhead at all. It's super fast. It uses a very small amount of bandwidth. Each of those, that physics simulation is running about 7.5 kilobytes per second. It's encrypted end to end, and we've already demonstrated on 5G networks, which why that's important actually is because we're looking at 5 to 15 millisecond latencies in the near future on those kinds of platforms. That's really going to matter for augmented reality. Sum up, Albert Einstein has this wonderful quote, "We cannot solve our problems with the same thinking we used when we created them." That's so true. We have to find new ways of thinking, and we have to do those collectively. We have to solve the problems of the future collaboratively. That's the only way we're going to be able to do super hard problems, and we've got so many of them, and in fact, they're existential. This is the time for us to get collectively smarter. Thanks.